Now we have the estimated regression equation y hat equal to b sub 0 plus b sub 1 x sub 1 plus b sub 2 x sub 2, where x sub 1 is the size of the house in 1000 square feet and x sub 2 is 1 if it has a fireplace and 0 otherwise, and y hat is the assessed house value in $1,000. Now let's first interpret the slope coefficients and then see how we can use the predicted equation to come up with point estimate of y. The first one is b sub 1 is 49.821, and remember b sub 1 and b sub 2 also, okay, they are the same units as your y. So y is in $1,000 of assessed house value, so 49.821 is 49,821 of assessed house value. Okay. And b sub 1 tells us that's the amount by which the assessed house value will go up if x sub 1 goes up by 1. So x sub 1 is in 1000 square feet. So x sub 1 going up by 1 means for every 1000 square feet of additional space, the assessed house value will go up by $49,821. Okay, and then the caveat, okay, for the same status as far as the fireplace is concerned. Okay, fireplace being the same for a house that has a fireplace, when 1000 square feet of increase will result in this, and if the house does not have a fireplace, can again between two houses that have no fireplaces, okay, so each additional 1000 square feet will result in that amount, that 1000 amounts on assessed value. The assessed value of a house is estimated to go up by that many dollars for each additional 1000 square feet, because the area is in thousands. So each additional 1000 square foot of area given the same status with respect to the fireplace. Now b sub 2 is about fireplace. So given the area is the same, okay, area is the other independent variable. So given the area is the same, how much the price assessed value of the house will increase between 0 and 1, 0 being the base. So compared to no fireplace, having a fireplace will increase the assessed house value by that amount given the same square footage of area. So given the same square feet of area, the assessed value of a house will go up by 12,162 if a fireplace is present in the house. Now let's look at how to do a prediction for the dependent variable y in this model with dummy variables. Suppose we want to predict the mean assessed value of a house with 2000 square feet of area with and without a fireplace. So let's first assemble the slope coefficients for the model, so which are here. B sub 0, B sub 1 and B sub 2. So that's B sub 0. Now we can copy this down to get the B sub 1 and 2 values. Okay. Now we need to set up the x values for this column. Okay. We'll leave B sub 0 alone. B sub 1 corresponds with x sub 1, and x sub 1 is area of the house in 1000 square feet. So for a 2000 square feet house, you should enter 2, not 2000. If you enter 2000, that would be wrong. So you have to convert the value into the unit in which the sample data is expressed. And there is no fireplace, that means x sub 2 is 0. And here again 2000 square feet, and there is a fireplace, so you put a 1 there. Then y hat is b sub 0, and we will make that into an absolute cell reference so we can copy this y hat formula over to the next cell. Okay, plus b sub 1, make that absolute reference, times that cell, plus B sub 3 and make that absolute reference times X sub 2. Copy that. Okay. So what this means is the assessed value of a 2000 square feet house without a fireplace is estimated to be $369,061, and with fireplace will be $381,224.